And there we go, the recorder is on. Alright, so what we'll do today is to talk about TinyWebDB. Okay, so we talked about TinyDB already, which stores information on the device itself. But this time we'll talk about TinyWebDB, and you can find that in under storage. Right below TinyDB is TinyWebDB. What I'll do first is I'm going to click on the help information here. So we'll start with this. Okay, TinyWebDB, non-visible component that communicates with a web service to store and retrieve information. In many ways, it acts just like TinyDB. Okay, but it is going to store information remotely, so nothing is really stored on the device itself. So on the surface, it's really good. Okay, so let's take a look at what it needs in order to work, and what kind of event it has, and what kind of methods it has. The only property it needs is a service URL, which is a URL to a particular website where it can store information and retrieve information. And the way it stores information and retrieves information is in the way of a URL request. So it's not unlike a regular get or post request that you normally have to send in order to request something from a website. So that part is, it has a default value. The default value will set you up to work with the toy TinyWebDB service that is already set up by App Inventor. In terms of methods, I'll go over the methods first. The first method is get value, which is the same kind of get value. You give it a tag and it will retrieve any value that is already stored using that tag remotely. But this one does not return the actual value. We'll talk about that in a little bit. And the second one is store value, which means you give it a tag and then you'll give it a value to store. Just like with TinyDB, you can store any value you want. You can store a string, you can store a number, you can also store a list. Okay, so all of those things can be stored with TinyWebDB, just like with TinyDB. Now, let's go ahead and take a look at the events. Once you call the get value block, it returns almost right away. It returns right away after the request is sent. But it doesn't mean that, oh, okay, we got a value now. So when it returns, it is simply saying, okay, I got your request sent already, but you don't have anything yet coming back. When you have something coming back from that request, the event called got value will be triggered. So only at that point you can actually process what you got back from TinyWebDB as one of its arguments. When you call this block store value, it's the same thing. It returns right away as soon as the request is sent out, out of the device. But it doesn't mean that the value is actually stored at that point. If you want to confirm that the value is actually stored, you have to wait for the event value stored to happen. Then that means the value is actually stored. Okay? So are there any questions about the general setup of TinyWebDB in this example?
Well, you said you have to wait for it to happen. How do you find out when the wait is over?
You have to wait until one of these events happen. Or the third one, web service error, indicates that the communication with the web service signaled an error. So that means, okay, it has either timed out or the web service does not exist. Then you will get a web service error. Okay, or you lose network connectivity, at that point.
But how does it indicate to you that it's happened?
Say again?
Message web store show up on the screen or what?
Nope. Okay, let's go ahead and write an app for that. Okay, I got one app already written, but I'm not going to do that. I will start a new app just so that we know what it looks like, when we, start an app with that feature. Okay, so I'm going to start a new project called Test TinyWebDB. Okay, you guys don't have to do the same thing. It's going to be a very simple app. Okay, so this app is going to have a I'm going to make this simple. So I have a text box so you can enter something to store. I have one button to store the actual value, one button to retrieve the value, and then we'll have a label to reflect what is retrieved. Okay, so the tag is fixed in this case. So let me go ahead and change the caption first, just so that we know what it is. So this one is going to be storing the value. This one is here to load or retrieve the value, and this is going to be the value itself. And it's usually a good idea to change the name of the button so that I know which one we are talking about. So this is button store, and this one is button retrieve. Here we go. Okay. So now we have a general template already done. It's time to go to storage and drag and drop a TinyWebDB component into the whole thing. And you can see that as soon as you drop the TinyWebDB1 component, it has a surface URL that is a default value already. And by default, I'm pretty sure some of you cannot read it because it's tiny in terms of font. It's app in INV app inventor tinydb.appspot.com, and appspot is one of the domains operated by by Google, and it's really for scalable web applications to be deployed. So that's something that I will talk about next. Okay, I just want to give you a general idea of how to make use of TinyWebDB, and then we'll find out, okay, but can I have my own TinyWebDB? Because the way I'm doing it right now, anyone can go in and retrieve and change all that information. It does not belong to me because it's actually operated by somebody else. Okay, so now that we have all the blocks we have all the components specified, let's go to blocks and start some programming. We'll go to button store, and it will say when button store is clicked, we'll do the following. What we'll do is we'll go to TinyWebDB and say, let's go ahead and store a value. In this case, I'm making the tag a constant, and whenever I want to refer to a constant, I want to make a global variable for that. So in this case, it is str test tag, and we'll just define it to be the actual text of test. Okay, TEST. There we go. And now I can use that to specify here. I can just say get str test tag, and then the value that I'm storing is going to come from my text box. So I go to my text box 1, and then I specify textbox1.text, which is right here. I could type it too. Typing textbox1.text will work exactly the same way. All right. Now there's one thing you have to understand now is when this block is done, when store value comes back, it doesn't mean that the value is actually stored remotely. All it means is the request to store the value is sent out. Okay, it's out of the machine, but it's not actually stored. If I want to confirm that it is actually stored, then what I need to do is I have to go to TinyWebDB1 and then use this particular event to basically say, okay, the value is actually stored now. Okay, so I'm going to use this feature because what I would do is when store is clicked, I will turn off the retrieve button, because until I know it is completely stored, I don't want to send another request to retrieve a value that is being stored. So what I would do is I would disable the retrieve button by setting its enable flag to false. So this way, the other button will be quote unquote grayed out until the value is actually stored, which also means in TinyWebDB1.value stored as an event, I'm going to re-enable the retrieve button, because at that point I know the value just has been stored and now it can be retrieved. So I'm going to set retrieve enable to true in this case, like so. Are there any questions about this program at this point? One is to trigger the operation, but I don't know when it is done until I get the event in the second one. Is that okay? Sort of? Okay. We can visually see there's a slight delay. Yep, go ahead.
The check is actually there. How does that get triggered again?
It's not checking yet.
Okay.
I'm just enabling the button that will do the checking, that allows me to do the checking. But while it is being stored, I don't even want the button to be active because I know at that point it's not stored yet, so why even bother to click the retrieve button when the store operation is not completed? Okay? Alright. So now we can go ahead and handle the retrieve button. So with the retrieve button, when it's clicked, I'm going to do one thing. I'm going to use TinyWebDB1 to start the operation to retrieve the value. You can see that this getValue block does not return a value. Okay, it is just a block. It does not return a value. So that means if I put anything after this block here, after this purple block, if I put anything after this, it may or may not be able to get the value because the value is being retrieved at this point. Okay. In other words, this block is just starting the operation to retrieve the value. So while that is in place, I can go to button store and say, okay, since I'm retrieving the value right now, it doesn't make any sense to try to store another value at this very same moment. So I can now turn off the store button by setting the enable flag to false. And then when I get to this event here, which is when tinydb1.getValue is triggered, this event is triggered when an operation to try to retrieve a value is finished. Okay? There any questions about this one? Okay, let me just say that again. This block here starts the retrieval. This event signifies the completion of the retrieval. Okay. Now when it's all retrieved, then we have both, it will report back both the tag that I used earlier, which in this case is not useful because I only have one tag. It will also come back with the value corresponding to that particular tag. Yep, go ahead. Oh, I thought you had a question. Okay. Okay, so at this point I'm going to use my label and set the text of the label to the value that I have just retrieved, like so. And it is also a good time to re-enable the button to store a value because at this point I have no pending operation, still waiting to happen. Okay, so this is my entire program. Are there any questions about the program itself before I actually test it with a virtual machine? No questions? Okay, let's go ahead and test it. So I'm going to start the build here and go to the command prompt to start the actual virtual machine. And also get ADB ready. The virtual machine is just starting up. Alright, it's a little bit slower today. I don't know why.
Tabs is red. Error.
Yep. Alright, so now we can go ahead and upload the program. adb install-r test tinywebdb. Go back to the device, and the program is now installed as test tinywebdb right here. Alright, so we can test it pretty easily. We can just say Okay, this is a test string like that. We click store. You can see retrieve is grayed out, was grayed out for a very brief moment like that. So it depends on the network connection speed and also how fast the web server was able to respond to it. Now I can click retrieve to retrieve the string, and it is now retrieved. Okay, so it works pretty much the same way as a regular TinyDB, except this one is doing it remotely. The plus side of this is you can also, if you want to, you can go back to Designer and change the URL to use HTTPS, which is the secure version of HTTP, and it will work. Okay, I tested this already, so that means if you want to store anything that is quote unquote sensitive, you can transmit the data securely. You can also retrieve the data securely. Okay, but here comes the problem. When I sent that tag over, if I look at the blocks here, when I store something under the name test, if any one of you write your own app and try to retrieve that particular tag from that particular tiny WebDB, you will retrieve the same value that I have stored. In other words, the tag has, or when TinyWebDB stores something, it is the same for everyone. The only requirement that you need in order to store something, I think, is just an account with Google. Okay, so that means you cannot store something that is specific to you and it is separate from somebody else's data. That's a problem. Yep.
Couldn't the URL be just changed for a
Yes, you can.
particular user?
Yep. So the next thing I want to show you is, okay, so maybe I want to maintain my own TinyWebDB instead of the one that is published to everybody else. Okay, so let's go ahead and see how we can do that. Okay, so when you click create a custom TinyWebDB service, that link, you will be brought to the instruction here, which is actually somewhat confusing. Okay, it is actually more confusing than it needs to be, but I'll go ahead and show you how to do that. The instruction says, by default, okay, I'm just going to magnify this a little bit so we can all see better. By default, the TinyWebDB component stores data on the test surface provided by App Inventor, but it can only store up to 1,000 entries. After that, it is first in, first out. Okay, so what you want to do is to go to, not this spot here, but to create your own web surface, follow these instructions. Okay, so it's pretty easy to follow. You just go to that URL here, and this is that URL. I don't even want to bother with all this stuff here because there's one link down somewhere to let you install that remotely. Okay, create an application. Okay, there we go. I got one created already, so I have to create something else. Okay, the second instruction is to download this sample code. This part is actually quite useful. So I'll go ahead and download the sample code. It will download a zip file, save that zip file, but don't unzip it yet, okay? Because I'm going to tell you what you can do, what you have to do after you unzip it. And then we go back to the App Engine platform, and then go to appengine.google.com in order to create an application. Because what you're doing is you're cloning the application. I got one already here, so that's okay. I can create another one, and I'll show you some of the options. So I create another application here. I just have to find another name for this particular application identifier, and I have 9 left. Okay, because I used up one. You can have up to 10 applications for free until you have to pay Google to have additional applications. But I'm going to switch back to my command prompt here because there are a few things I have to do at this point. The first thing I have to do is to unzip the file that I just downloaded earlier for TinyWebDB, the application itself. So that one is, where did I download it to? It's under custom. Okay, I got the wrong name. There we go. Okay, so custom tiny WebDB creates a folder, and inside the folder there are a few files. The one file that you have to change or you have to update is this one. It's custom tiny WebDB / which is a subfolder. The one that you have to change is app.yaml, and with this one you have to change the application to your own name. Whatever name you want to use with App Engine is the name that you have to put here. Okay, so what I'll do is I'm going to change the application name to tax test. Okay, so that's what I need to do it here. And when I create the application, I have to use exactly the same name. So here I'm going to say tax test here. Check availability. It is invalid. Okay, what are the chances? Okay, fine. We'll make it longer. Test tinydb. There we go. Check availability. It is available. So test tinydb is available. We'll make it tiny WebDB. So this way, if we're long enough to describe what it is. So text test tiny WebDB is the application name. So these two have to match. Okay, you have to make sure that these two match. Application title, we can just say text, tiny WebDB test. Now here comes the most important part: is who do you want to have access to your tinydb database? You can say open to all Google account users, which is the default. You can say restrict to the following apps domain. If your application uses authentication, only members of this Google app domain may sign in. If your organization uses Google apps like ARC or Los Rios, use this option to create an application that is accessible only to accounts on your Google Apps domain. This option cannot be changed once it has been set. All of these options cannot be changed once they are set. Okay, but since I don't have a Google Apps domain, this is not an option to me. Okay, we can right click here and basically say join the 5 million businesses using Google Apps. So unless you have a Google Apps domain, you can't use the second option. Okay, and it's only for business purposes. So as an individual testing it, I don't have that option. So my only option, which is the last option, is experimental, open to all users with an open ID provider. If your application uses authentication, anyone who has an account with an open ID provider may sign in. It's still not ideal because they can all basically retrieve the same value from the same tag. So if you want to deploy an application so that your end users can each store, let's say it's a game and you want to store the high score for each person, it's not individualized. The way it is set up right now is not individualized. I can teach you some techniques or some tricks to make it individualized, but at this point it is not. So I'm going to pick the first option first and then say create application. And right after that, the application itself is installed. So here comes the third part. That is actually, it involves a little bit of text commands that we have to type. Okay, I don't have a dashboard because I'm running it, in Linux. If you install that, in Windows or on a Mac, you actually can get the dashboard to work, but I don't have that option. So we get back to App Engine here. And then this time we want to install a certain type of program onto my local machine here to finish the process. And we can go to Python. Okay, there's a download link somewhere. I did it yesterday. Download and install and unzip the Python Sdk. So this is what I need to do. And this is a pretty big package. Okay, this is a fairly large package. You can see it's a 50 3.6 megabytes, which is what I need to download here. I'm gonna save it to my local hard drive. And then unzip it to get the tools installed on my local machine here. If you're doing this under a Mac, Mac or in Windows, you have the graphical tools. But since I'm doing under Linux, I do not have those tools. Google App Engine. So it takes a while to unzip because it's a pretty large package. The package itself has 50 megabytes, which means after it expands, it can easily have 100, 150 megabytes. It's pretty typical that you get a 2 to 3 to 1 compression. Now that is way faster than I did when I did it at home. Way faster. Okay, so now we can go to that particular folder, and there are specific programs that I have to run. The only one that I actually need to run at this point is appconfig.python. So I just run appcfg.python with certain commands, and I just have to remember what one I need to use. Okay, so this is the command that I need to use is appcfg.py, and I specify and I think it happens every Monday and Wednesday at about this time too. Okay. All right, so we'll just go ahead and run this command. Okay, and we'll just put it here. Okay, so at this point, I have to specify my project ID or the name of the app. So this one has to be exact. It has to be tax. I cannot remember the name anymore. Okay, text test tiny web DB. Okay, so that part has to be exact, and then followed by the instruction here, update. And now we have to specify the folder where the app was uncompressed, and that was under my home folder / custom tiny web DB, and you have to specify the entire path name, and then you press the enter key. And I'm gonna choose one more account here, Dr. Tag Apps, which is the same account that I used earlier to create the application. And then the process will finish by itself. And it will complain because the application is using Python 2.5, but Google wants it to be using Python 2.7. That's okay, it's just a warning. It still works without any problem. Alright, so switching back to the browser here, and I go back to here, I can now go to the dashboard, the web dashboard for my test tiny web DB, and this is my dashboard, and it's running. Okay, at this point it's running. I can check how much traffic or how much the app is being used. So I can now go back to my App Inventor 2 and go to the designer, change the properties of TinyWebDB1 to match what I have over there on the other side. So now I have tax test TinyWebDB as the name, or the first part of the name of the URL, and I'm using HTTPS, just the same here. So when this is all done, make sure it's updated. Build the app again. So this time I'm using my own web address. It will not be a bad idea if I just intentionally put in a typo here just to see what happens. But I did not specify the block to handle the error. So if I wanted to test that part, I would also have to specify the block to handle the error condition. All right, so it's getting there, and here we go. Save it under the same name, and then go back to my command prompt here to. Oh, okay, I lost that one. Reinstall the app, okay, and now back to my emulator, but this time the emulator is making use of my custom TinyWebDB application. So let's go ahead and see if it works, okay. So using tags custom WebDB web TinyWebDB store retrieve, and it's all working. Okay, so here comes the next question. How is it actually being installed? If you go back to the dashboard here, I, as the administrator of this particular app, I have a lot of options here. I can go to data store viewer and find out what is being stored here. So the first one is ID equals blah 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 blah, and the tag is test. The value being stored is that. So I can click that one here, and I can see exactly the three fields of that particular database item, which is the date itself, the tag, which is a string, and also the value, which is a string. Okay, so but it doesn't contain any information about that particular app, and I did not have to sign in on the virtual machine to get to this part here. Okay. Now, if I download that app, the APK file, to my cell phone, I would be able to do exactly the same thing, and without storing anything, I can retrieve exactly the same value. Which means if you deploy an app like this, every user is going to use exactly the same entry in your TinyWebDB, which is probably not what you want to happen. Unless you want them to share some kind of data, but even so, you probably do not want them to share exactly the same item. Does everybody understand the limitation? We went from a per device ability to store something, which is TinyDB, to a universal way to store something, which is not per device, it is not per user, it's not per Google account, it is universal. Okay, so it doesn't matter where this app is running from. When this app runs, it will go to this particular tag and change or up. It will either update or retrieve this particular value. It doesn't matter, who owns the device or which device we are talking about. Okay, so here is my question to you: how are we going to fix this problem? There are several ways to do it. Well, the first thing we can do is we can change the tag. In other words, if you want your setup to have a sense of users, you will have to manage your own user setup. Okay, and you probably want to. Yeah, that would be good. That's going to be interesting because how are you going to let people authenticate? You cannot use TinyWebDB for authentication purposes because every single device will now have the password or have access to all of your other users. So you need a way to establish, the sense of an account or a user first, and then what you can do is to change the tag to reflect the user. In other words, you can basically say, okay, let's say OyongT is the username. So now the tag for this particular item is preceded using a prefix of the user's name. Now that is not the most secure way of doing things because people can guess. Okay, so if I know that someone always use a particular username, I can try it out. I can test it and see whether that person has an account or has values already stored in this TinyWebDB. So that means TinyWebDB, as far as I'm concerned, is a cool feature, but it's not really ready for prime time because there's no authentication support and there's also no per user support either. Well, one actually leads to the other one, but basically you cannot do anything that is on a per user basis, and that's just not going to work for a lot of applications. Are there any questions about what I have just talked about today? No questions?
How long can the tag be?
How long can a tag be? Well, since it's only of the string type, I would say it can be as long as you want it to be. I mean, well, obviously not like infinitely long, but it can be easily 64 kilobytes or more. I don't think it has a limitation to in the order of kilobytes, probably more than kilobytes.
Then you can have no problem making it unique.
Or you can make it unique, but the question is, how do you make it unique that you cannot guess it? Like if I know somebody else is always going to use a particular username, I can now, kind of poke the database to find out, whether that person has an account here. So it's good, but it's not good enough because it has no user authentication mechanisms whatsoever unless I operate my own domain. Now, if I operate my own domain like lostreals.edu is a domain that has a Google app engine associated with it, then everybody in the domain can access it. So I still do not have a per user authentication means. In that case, it's just the whole domain. Okay, it's still not on a per user basis.
Well, this type of setup, although it's not really secure, you can add a tag with the password and compare it on the device itself. Maybe use like an SSL connection and sort of do some special processing so it's not as apparent to how it's verified.
You have to use a secondary method to store the password. You cannot use the same method to store the password because it's not gonna.
First, you check the username tag, which is okay. Then you check the password. If it's not okay, then do not retrieve any tags, any other tags.
I see. So the app would still retrieve both the username and password in order to see if they match or not.
Still not secure, but
it's
still
definitely
something.
not secure. It's definitely not secure. Because with any type of authentication, you don't want to retrieve the password to the local side to compare. You want the server to do the authentication. Yeah. You want to supply the password and say, hey, is this working or not? So what you want to do is to do it kind of in the opposite way. So the way you do it, the way I would do it, is to store a tag that is both the username and the password remotely, but not using this app here. Use a third mean to do it. Then the app will just try to retrieve it. Now, if it can retrieve it, that means the authentication is successful. If it cannot retrieve it, that means the authentication is unsuccessful. And therefore, it's not going to work. The rest of the program should not, continue. But that's still, not definitely not something that I want to do because you don't want to store passwords in plain text in any type of database. Even if Google says it's completely secure, it's still not a good way to do it.
And it doesn't have really a proper way to do hashing.
Right. Yeah, you need a really good hashing function too, because some hashing functions are basically pointless. They have a way to look it up anyway. Okay, so that's basically the first part is, okay, we have a mechanism to do it, but it's not secure. Are there any questions at this point?
Question.
Yep, go ahead.
How do you delete data?
How do you delete data?
That's put in
As an administrator of the application? That's pretty easy, because I can go to, let's see here. Data store, viewer, get back to here, and I can just click check it, and then click delete. So as an administrator of your own custom TinyWebDB resource, you can delete anything you want to. Okay, you can remove things, you can delete things, you can do whatever you want. Excuse me. But if you're a user of the app making use of this service, then you don't have that option. You cannot delete anything. In other words, from the app's perspective, if you go back to the apps, go back to the blocks here, and you go to TinyWebDB1, okay, there are no options here for deletion. You can only store and retrieve, but you cannot remove, you cannot delete. So I would say this feature is nice. It's a good attempt to make TinyDB work across the internet, but because of the lack of authentication, it is not really ready for prime time. It's just not ready. Now, the second thing I want to show you, especially for those of you who want to kind of figure out, okay, but how does it work in the back end? Now, here is kind of something that's kind of interesting, because what you can do is you can go to, not here, but go to the folder where the app is installed. Now we'll go back to app.yaml, which is a markup language. It says the application name is text test TinyWebDB. That part is really just naming the product. Version is naming the product. Runtime is telling me what kind of programming language it is written in. It has handlers and whatnot. But the most important part is here. The script is main.py. So that is the most important part, because if you look at main.py, which is a Python program, and I can turn on, well, I'm not going to turn on syntax highlighting because that's going to be a little bit difficult to read. This is the programming language. This is a program written in Python. But if you want to find out what's happening here, it specifies a web page first. In other words, if I go to that particular URL, which is text test tinywebdb.app engine, no, it's app, what is the name of the URL? appspot.com, appspot.com. Then I see this page. This page is basically specified here. Okay. So this part here is specified by intro message, okay, which is what you see as the quote-unquote home page of the website. Okay, so here's main page, and it does all the other things. Now here comes the most important part, is the class to store a value. This is how it stores a value, and to handle the post, to handle a get request, and then to get a value has its own class. Now I'm not going to teach Python programming here, nor object-oriented programming, but for those of you who have exposure to Java or C++, you probably can recognize some of these things, okay? Because when you define a class, you can define methods inside the class, and then within the methods, it's just specifying what you want to do when that particular method is invoked. Okay, we also have delete entry as a class. Procedures used in displaying the main page, generate the page header, show stored value. Utility procedures for generating the output. Writing to the web, writing web footer, save delete key. What I'm actually looking for is linking the words store value to the procedures. Store value is one word. Store a value. Store a value. Okay, this is the key to it. This is how this particular application is registering its own method, or in this case, the class to store a value, to the URL specification, the URL path of store a value. Now, if anyone wants to extend, this particular application, which is actually running on Google hardware right now, you can extend this particular file, include additional classes for signing in, for users, and then you have to change all of these procedures, because everything that you store is no longer just a tag and a value, because it will become username or user ID, tag, and then the value. But then you also need other procedures for signing in and signing out. But it can be extended to do what I just said. It requires some additional programming in Python. Excuse me. It requires some additional programming in Python, but it can be done, and I think this is a good foundation to build upon. If you want to add user support for TinyWebDB. Any questions?
Question.
Yep.
Is Python the language specifically for use with Linux?
No, Python is just a programming language. It is not specific to a particular operating system. Google allows you to use any one of the 4 programming languages supported to write your own app. Okay, if I go back to the App Engine page, you can use any one of these 4 programming languages for to write your app. App Inventor from MIT decided to use Python for that purpose, but they could have chosen Java or PHP or Go. I personally don't even know the language Go. I think that's a gopher. So are there any questions about what I just mentioned?
Question.
Yep.
Have Los Rios ever taught Python or PHP as a class?
PHP, yes, but not Python. The thing about learning a new programming language is once you have learned one or two, learning additional ones, you can pretty much do it yourself. Because it's almost all programming languages share the same common core of features, like how do you define, what is an assignment statement, what is a loop, what is a function, a procedure. Those are all pretty much common across all programming languages. If you want to learn how to learn how to program in Python, just look it up. Just look up your Python tutorial, and now you have a gazillion links to teach you how to program in Python.
How does Los Rios decide to stop teaching a language or to start teaching a language?
It's all based on faculty. If I think that there are enough people to fill a class, if I want to teach Python, and I can link that class to one of the degrees or certificates that is already being offered, or I can make a new certificate to offer. If I think I can fill that class, or you have enough people to sign up for that class, I can make a new class. On the other hand, if I think maybe there will not be enough people who are interested in Python, or I cannot link Python to one of the degrees or certificates that we already have, then it may not be a good idea to to make a new class.
why has Los Rios stopped teaching some languages that are widely used in the industry?
Such as?
Fortran and COBOL.
Well, they were widely used, but Fortran I know is not widely used anymore. COBOL still is. The question is, can I fill classes? Because if I don't get 22 students in a class, the class gets canceled. So it may be a programming language that is widely used in industry, but if I offer that class and I cannot get 22 students in the class, at least at the beginning of the semester, that class gets canceled. So there's no point in offering that class anymore if I cannot fill the class.
Well, there used to be a dozen sections of Visual Basic, and now there's only about 2.
There used to be what?
A dozen different sections for Visual Basic.
Right.
Now there's only about 2 or 1.
I don't
Is that
remember.
because they teach in high school now?
I don't know. We are having more classes teaching C and C++ now. So maybe it's a shift of focus. We're having more people learning C++ or Java programming, and fewer people learning Visual Basic. I don't know. All right. So are there any questions about what we just talked about earlier today? No questions? Nobody wants to take on that task to extend TinyWebDB to include authentication? Actually, in your case, if you might want to look into the App Engine concept, because the App Engine concept, is actually pretty cool in a way, because your app is running on Google hardware, and until you hit a certain limit, it's free. So it's almost like web hosting, but it's not a website hosting. It is actually an app hosting. So you write your application using Python, Java, PHP, or Go, and you write your app that is actually intended to be used by other applications. So it has a URL. You specify a particular type of URL to access it, but you don't pay anything for storage. You don't pay anything for bandwidth until your app takes off and you actually generate the bandwidth or processing requirement that that requires you to start to pay Google. So you don't have to run it on your own website anymore, and the data store backend is already done. I mean, if you look at the Python program, it's already done. If you look up, let me just go back to the beginning and look for that keyword again. So this is how it actually does something with the database. So the linkage to the database is already done. So the rest is really just your code, to specify what you want to do. So something to consider, because now you don't need to have your own website. If you don't need an actual website, you just need a service. This is one way to do it, and you can do it for free for I think 1 gigabyte of storage or something like that. I mean, it's huge for something that is free.
Question.
Yep.
I forget, what is it exactly you're going to have 10 of before you start paying?
Well, let's take a look. Okay. Okay, so let's start with what is Google App Engine. And we'll up the font a little bit, because I think this is interesting as a companion to writing applications. I don't even care whether you're writing your apps in Java or App Inventor or writing it for iOS devices, because it is a useful concept to make it cloud-based, so that when you store data, it is stored in the cloud and not on the actual devices themselves. Google App Engine lets you run web applications on Google's infrastructure. Okay, so let's just take a look at the highlighted part here. What exactly is a web application? What do you think? We all know about web pages, right? Fancy web pages with cool graphics and whatnot. A web page is intended for a person to view and get information out of, to interact with, right? Does that make sense? You go to Amazon.com, you get all kinds of splashy, flashy images, and today we have a sale, blah 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 blah. That's intended for end users like you and I. What do you think is a web application instead of a website or web page? What do you think is intended for?
It mirrors the desktop application that runs on the web.
It can be that, yep. It can also be an application, quote unquote application, that is designed for other programs to interact with. It's a web service. In other words, you're only using quote unquote the web as a means of communication. So you're using HTTP as a protocol for communication. You're using URL to specify the destination. You're using the URI standard to specify the request and so on and so forth. But it's not really intended for someone to interact in person. It's intended for another program. It can be a Visual Basic program running on a PC, can be your App Inventor application, but it's for a program to interact with. Okay? So that's what a web application is it can be user-oriented, but it can also be application-oriented, which means it's intended for other programs to interact with it. App Engine applications are easy to build, easy to maintain, easy to scale as your traffic and data storage needs grow. Okay, now let's take a look at this part here and see what does it mean by that. And I'm not even promoting Google, because I'm pretty sure its competitors like Amazon and some other places may offer similar and competitive pricing for something like this. But this is a concept that I think most people should really understand, because this is the shift. Okay, people are shifting into this type of paradigm. Okay, so let's say you're running an app. Okay, we'll pick a particular app here. Okay, I just had this idea this morning, so I haven't really started an app yet, but it's possibly an app. I'm a really messy person. Anyone who has visited my office will know that. Okay, I just don't organize physical space in a reasonable way. Okay, so it's easy for me to lose items. Okay, where did I put blah blah blah? Okay, I need to find it. So maybe I want to write an app to help myself and other people in the same boat and say, okay, let's use an app to help me organize something. Because one of the key concepts of organizing physical items is, well, I need to know where I'm supposed to put it. Instead of just putting it on the table or on the shelf, where am I supposed to put this, blah blah blah. Okay, so let's say I write an app to do that. I don't want to store that information of where I usually put something on this location on the app, on the device itself, because what if I lose the device? What if I drop it? What if I step on it or roll it over with my car? All that data is going to be gone. So I want to store it on the web, or use the concept of a web application for that purpose. So when I first start, maybe I write the app as a personal project, okay, because I'm just using it to help myself organize my stuff. But as time grows, maybe the app becomes usable to other people, and I would want to start to sell the app, maybe, okay, or use whatever means I can to monetize the app. Okay, maybe using advertisements, I can sell the app, I can sell the upgrade, and so on and so forth. Doesn't matter. Okay, so at some point, my infrastructure requirement is going to go from maybe 20 megabytes at the most, for personal use, to gigabytes. But at that point, I'm making money out of the app. So what do I need to do with this end and say, well, you know what, my app is now needing more storage, it needs more processing power, and so on and so forth? Absolutely nothing. Because on this side, with the Google App Engine, it scales up the allocation of resources accordingly. It looks at the traffic pattern, it looks at how much processing power is needed by the app, and it would just throw as much processing power, storage, and network bandwidth as it needs. Unless I set a limit and say, okay, don't give it any more than this, then it would just cap it at a certain point. Okay, so that's what it means when it says easy to scale as your traffic and data storage needs grow. So that means you don't have to worry about it. If you try to run your own server, okay, has anyone tried to set up and run a web server or database server? Okay, can you easily scale up, the allocation of resources? Like, I'm going to throw 5 more cores to this application.
Never had that issue.
Okay. But potentially, if you run an app or write an app that you think, well, I might sell millions of this, millions installations of this app, you can run into that kind of problem quickly. Okay. It's not like, you run into this problem very slowly. Okay, the first year, my web server is starting to get slow. Maybe I can upgrade it now. And then the next year, you say, well, maybe it's getting a little bit slower now, and I still have time to upgrade. Okay, I can upgrade today, tomorrow, or next week. With app selling, how quickly can your user base build up? Assuming you're lucky and your app is successful, how quickly can it build up? Over at the most a week. Okay, you can grow from 1 to millions. Okay, you don't have time to go to Fry's to say, I want to buy a new motherboard. I want to shut down my service to build a new machine with a new motherboard and port all the data back to the new machine. You don't have time to do that. You cannot shut down the server, or otherwise you lose your clients, you lose your customers. And that's why this type of thing is useful, because they can throw more resources on your app whenever it is needed.
You can do like a URL redirect to offload it while you're upgrading.
Right, you can do that. Yep. With App Engine, there are no servers to maintain. You just upload your application and it's ready to serve your users. This is definitely a new trend. It's not just Google either. As far as I know, I think VMware, okay, the company that actually makes the software VMware, they are looking in this direction as well, because they used to virtualize an entire operating system. Okay, you can run Linux as a virtual machine, you can run Windows as a virtual machine, you can run Mac OS X as a virtual machine. That's the usual model of virtualization. But they realize that when you virtualize an entire operating system, there's a lot of waste. Okay, because if you have 5 virtual machines, okay, all running Linux, the Linux portion is now wasted because you have 5 copies of pretty much the same thing, even though the only part that is different with all 5 virtualizations may be this much compared to the entire operating system, which can be substantial. Okay, so even VMware is actually looking into virtualizing applications, not operating systems. And I think Microsoft is probably going in that direction too. Okay, they're virtualizing on a per application basis and not on a per operating system basis. Say again?
What's the advantage of that again?
Of this?
Not virtualizing the whole operating system, just the application.
You are saving resources. The service provider does not need, okay, if you're virtualizing Windows, okay, you're taking up 1 gig of RAM just to run the operating system itself. So now your application is on top of the 1 gigabyte of overhead. Now if you do not virtualize the entire operating system and instead you virtualize only on a per application basis, then you don't have the overhead of 1 gigabyte per customer.
If you virtualize the application, will it run on any operating system?
It basically is up to Google to decide what operating system they want to use to run your application. But your application is now, it is still independent from all the other applications, but it doesn't have an operating system to attach to anymore.
Okay, but I mean, will it run on Windows? Will it run on Linux? Will it run on...
It should, because Python is a programming language that is available across all the platforms. Yep. It's just that when you can test it locally, okay, you can test it locally on Linux, on Windows, and on Mac OS X just to see that it works. But when it is time to deploy, you just let Google decide whatever operating system they think is going to work. They will pick that one. And I'm guessing that Google is picking Linux, because it's cheap to license and it's reliable. But they may not. They can choose to write their own operating system if they want to. As long as it can run Python, it's fine. You can serve your app from your own domain. using Google Apps, or you can serve your app using a free name on appspot.com, which is what we just did. You can share your application with the world or limit access to members of your organization. Google App Engine supports apps written in several languages, so there are those 4 that we just talked about. You can do it in Java, you can do it in Python, PHP, and also Go. You only pay for what you use, no setup costs and no recurring fees. It costs nothing to get started. You can use up to 1 gigabyte of storage and enough CPU and bandwidth to support an efficient app to serve around 5 million page views per month, absolutely free. So we are talking about, this is a pretty big, allowance. I mean, if you think about it. Yep.
Could you also sort of get around that by chaining them together?
Have a little load balancer. You're like, oh, okay, it's your turn here. I think if you want to do it that way, I don't think Google will even try to stop you. It's not, they're not going to profit a lot from people who are kind of doing that, to begin with, because, they're profiting from people who are corporate type of organizations, okay, big, huge corporations, where they need so much resources, they don't want to even play with, reducing the cost. Because just the fact that you don't have to run your own server, have your own server farm, is already saving these organizations huge amounts of money. And they don't care that they have to pay, additional money per, terabyte of storage or whatever. I mean, it's like, okay, we'll let you do it. Are we doing okay so far with the concept? Okay. So they talk about the application environment, the sandbox, which means you are protected from the rest of the other users. The other apps cannot touch your app in terms of what you can store, what you can do with your database. The workflow is how do you develop applications like this one? I think I can turn this into a class. Okay, just write, have one class to teach only about, web applications. I don't have to pick, Google. I can pick, some of the other, competitive services. But this is where things are going. Yep.
Can you go back to the top?
Yep.
Right there. Might be kind of early, but can you explain that to me? The second paragraph, first line, what that means?
You mean this part here?
Yeah.
Okay, this is this college district is a good example. Okay, because what it means is you can now say, okay, if you go to apps.losreals.edu, it is not a Google URL. But yet, when you get there, okay, let me sign in first. I know that. Oh, I did not. No, I don't want to change it. I clicked the wrong link. Okay, let's try that again. Cancel. Here we go. Okay, so you can see that from that particular domain I was brought into here, but the username W00068887 does not exist as a Gmail account. It does not exist as a Google ID, because that is an ID that is local to lostreals.edu. So that's what it means, when it says, integrating. Where were we? Okay, we were here. This is what it says. This, or part of it means, is what part of what this means is what I just demonstrated. You can serve your app from your own domain name, which means you do not have to use appspot.com as the URL of your web application. So you can, in other words, you can brand your application. So when people see it, it is not under app.appspot.com, it is under your own domain name.
But everything would be from
It's still run by Google.
Yeah.
Yep. And they probably do this by a few different tricks. One trick you can do is to use a domain name service. You use a DNS server. So that means when I type anything like arc.lostreals.edu, the domain name service will map it to one of the servers within the district. Okay, but when I go to apps.lostreals.edu, it can map to a IP address that corresponds to a Google-owned server that's sitting somewhere other than within the district IT infrastructure. So they can do it that way. There are other ways to redirect services too, but basically they're saying that yes, you can. You can basically brand your application so that it appears to still be within your own website.
So is this talking about an app on a phone?
No, this is talking about a web application.
Okay.
Yeah, not on the phone, but a general web application. Just basically anything that you can specify as a website, as a web page, as a script that runs through a web engine. That's basically what they're talking about. In other words, it can be end user oriented, just like a normal website, but at the same time it can be something that's like what we just talked about, the TinyWebDB, which means it is entirely designed for other programs to interact with, but not really end user oriented. So you can do it in both ways. Okay. Any other questions about what App Engine does and why it is at least an interesting concept? And I think it's going to catch on pretty quickly. If you go back to the first page here, why should I use a web engine? I think we actually talked about that already. Yeah, easy to scale. We got all that stuff already. There's one place where it explains who is using it already right there, used by millions. I'm not sure whether you recognize some of these names, but I think one you should recognize already. Who's this? Who is Rovio? Come on, you guys should know it.
Angry Birds?
Angry Birds. Yep. And Khan Academy. Does anyone know what is Khan Academy?
Didn't you talk about them this semester?
No, I did not. It's probably Dave Larrabee. If you have taken classes from Dave, he likes Khan Academy a lot.
Online course. You teach online courses at Khan Academy.
Right. It started off as a guy, doing YouTube stuff, exclusively. But I think, it is now a lot more than that. It probably has tests in assessment and, actual curriculum, for his stuff now. In fact, we can take a look. Okay, business on Google Cloud Platform, making use of Google application. So we can take a look at Khan Academy. It's a non-profit organization. It's for education. It's a a vast collection of free educational online videos about math and science topics. It's actually more than just math and science. The guy actually talks about a lot more than that. Millions of students, educators, and self-learners around the world watch the videos, and so on and so forth. The challenge: ask him to take a website for several years, but the platform experienced limitation. Well, he's not using the app engine in terms of using the programming part of it. He's really just using it to host his 2,000 plus videos, which is just the indexing and the sorting and also the organization of the videos. But as far as I can see, he's not using app engine for anything, just using the bandwidth and using the storage, but he's not using the actual custom coding part of App Engine. Okay, so that is that. Best Buy developing apps on. Okay, with Best Buy, I'm assuming they're using Web Engine to host their actual website. So when you order stuff, through BestBuy.com, it's actually going through their App Engine code that is hosted by Google. So let's take a look here. Okay, in 2008, a team of Best Buy developers launched GiveTag, a social application that let users make online wish lists to share with friends through email, Facebook, Twitter, and other social media sites. The app is promising, but the development effort was substantial. It took 8 developers more than a year to create the app. Once it was developed, adding new features and scaling it for heavy use was onerous, difficult. The development platform we have selected just wasn't cutting it. I'm guessing they were using Microsoft, but that's just my guess. Because of the platform design, an application administrator had to make changes manually, blah, 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 blah. The solution is to use App Engine, Google App Engine. The payoff was immediate. Best Buy developers rewrote the GiveTag application from scratch, improving the original code while only having to do an extract, transform, and load on the existing data. The entire process took 4.5 developers, just 11 weeks. Half the development team in 25% of the original time. So that's 1/8 of the cost, basically. The time saving enabled Best Buy to relaunch the app just in time for 2008 holiday shopping season. So this one actually includes the code to do things using Google App Engine.
Question.
Yep.
What is that again? A wish list for friends? That's to tell people what to buy you for a birthday present?
Christmas, I would assume they're talking about Christmas.
Or a bride register. Or a bride's register. For wedding gifts.
Or that, but they said they were just in time for 2008, shopping season. So the only shopping season that I know of is the Christmas, shopping season.
Just let your friends know what you want them to give you for Christmas.
No, yes. Well, pretty much. You basically say, these are the things that I want. So one friend may say, well, I'm already at Best Buy and I'm already in this aisle. I'm shopping for stuff for other people. Oh, okay. I check. Tech wants to have a, blah blah blah. So I'll pick one up and click it on the phone. So that way, that item is taken care of. So in other words, you don't end up with 20. Gamepad controllers just because you told everybody that you wanted a gamepad controller. I'm just looking for one that is web-based. Let me see if I can find a Rovio right there. Google App Engine allows us to launch games very quickly with teams of 1 or 2 developers per game. Because Google manages all the servers, there's little required of us in terms of maintenance. Okay, let's take a look at this one because I want to see, whether it's linked directly to mobile apps or not. Challenges. Bringing its games online present an enormous opportunity. So these, okay, with Rovio, they're actually making their games online, I guess, accessible through a web interface. How many people have tried to play these games, that is completely online? No? Okay. Rovio. Alright, so there we go. I'm not sure whether this is the legit one or not. Doesn't look like.
It looks like mostly games for children.
It's for people who want to understand physics.
Or we're bored at work.
Yep. But basically, I think this is an interesting, platform. Unfortunately, it only supports, certain programming languages, and not the one that I use most. Okay, I use Perl more than I use, any of the other programming languages. But that's okay. Switching a programming language is not the end of the world. It's really just a matter of days in some cases to get used to a new programming language. But the opportunity is interesting because now it basically says you don't need to run a server. Okay, if you want to, make use of, if you just want to publish a web application, you don't need to spend the time to put together the hardware. That's way, in the past. Okay, because we got virtual machines. But this also says, you don't have to deal with the operating system or setting up Apache or do all the maintenance, all the system updates. Leave it to somebody else. You just focus on the application, and it's not revolutionary, but it is evolutionary because we are basically focusing more and more and more on just the application. The supporting stuff, hardware is the first one to go. The operating system is the next to go. The web server itself is another one, the next one to go. So we are only left with just the custom code for a particular application now, which is what people want, which is what developers want, because they don't want to waste any time to do the rest of the maintenance of the infrastructure. I think it's very interesting, and for this class, I think it is interesting in a way that you can easily set up a server, a web application using AppSpot, and do what you originally intended to do. Because remember, you had to custom write your PHP scripts and all whatnot in order to make it communicate with your Google app, your Android application. With this, you don't have to tag it onto your existing website. You can just start a particular application with Google App Engine and just do it through Google App Engine. And it doesn't seem like it's a very difficult thing to do. It's just a matter of getting through the infrastructure, how to set up an application, and the framework that we have learned from the sample programs should be enough to get you started. And PHP is one of the supported languages too, which is nice. Yep.
Before we were just gonna check out to see what an object would look like in a TinyDB.
Oh, okay. Okay, so the question is, what does an object look like when we use TinyDB? All right, so we'll just go ahead and hack this program a little bit and make it work that way. Okay, so when we store the value, I'm not going to store something from the text box, and we'll just pick an object to store it. And let's pick something that is interactive and is reasonably complex. So we'll pick text box 1 and see whether it plugs in. Yep, it does, surprisingly. Then we'll go ahead and run this. Probably not this semester, but I think maybe within the break, I'll look into adding authentication to TinyWebDB. That'll be a little project. All right. So the first thing we do is we go to the virtual machine and run the program and say store. But the retrieve is going to be interesting because it's going to retrieve an object. and it says da 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 da. Okay, so now we go to the Tiny Web Engine here, and we take a look at the data store. Go refresh. And that is exactly what it stores.
So it's just reference.
Yeah, it's just a reference, and it cannot store the actual, object. But it does store the name of the, it stores up to runtime text box, which is the name of the class, I would assume, that is stored internally. But the other part is probably an address or reference within the Java program. And it cannot resolve anything after that. So there you have it. All right. So we are running out of time today, and that basically concludes today's recording.